Hello, Chemistry 10HH students. This is Mrs. Altman. We are on video number 26, Types of Chemical Reactions, Part 1. This is the first video from Chapter 4 in your textbook. Here are our objectives for today's video. Pause here. So you've probably seen this before in biology. We've talked about water, the fact that it's got a portion of it that's partially negative charged and the portion that's partially positive charged. Those symbols there, those are the Greek letter of delta. I know it looks kind of similar to a Hebrew letter. It just means a partial charge. So when you have a separation of charge, the whole molecule can be referred to as a dipole or a polar molecule. The reason why this occurs is because oxygen is far more electronegative than hydrogen. So even though these bonds are covalent, oxygen has just a little bit more what's called electron density around it. Pause here. So solubility, if you did not already know, this is just when something dissolves in something else. So it's forming a homogeneous solution, which is different from a suspension, which would be something formed a heterogeneous mixture when it mixed all together. So we're talking about when typically water is going to be our solvent for just about everything in this chapter. And water will pull compounds apart, and that will cause them to dissolve. This is called hydration. All it means is just dissolving in water. Pause here. So if something dissolves, then it might be able to what's called dissociate, which means that you would have moving charged particles. Electrolytes are things that dissociate, and they're going to conduct electricity when they dissolve in water, and that is because they are forming things that have charges that are able to move. Many electrolytes are ionic, like sodium chloride, for example. Not all of them are. You could have things that just have very polar covalent bonds that are still able to be electrolytes. They don't tend to be very strong electrolytes, though. Pause here. Right, so in order to be an electrolyte, there has to be dissociation. Dissociation means that we're just breaking things apart. So for example, instead of having NaCl, I've got the Na plus ion going one direction and the Cl minus going a different direction. Things that are strong electrolytes, they completely and 100% dissociate in water. So if I have NaCl that is dissolved in water, there is not a single unit of Na and Cl together. Whereas weak electrolytes, they still will conduct electricity, just not nearly as much, and that's because they only partially dissociate in water. Hydrofluoric acid is an example of that. Sugar is an example of this as well. Pretty much all weak electrolytes, for the most part, are going to be covalent. Pause here. Right. So when we are talking about dissociation reactions, we're talking about what actually happens when something breaks apart in water. So polyatomic ions are going to stay together because this is still considered to be a physical reaction, though it is a little bit of a gray area. And things on the left will typically be solids if they are ionic, meaning that they're type 1 or type 2. For acids, they will be aqueous. And then on the right, we're seeing that the ions that form, everything has to be balanced, just like it normally would be. On the bottom, the reason why I use the double-sided arrow is because HF is a weak electrolyte. For just about all of these, I'll put in the question, or the book will say in the question, that you may assume that they're strong electrolytes, so you could just use the standard forward arrow. Pause here. Okay, let's go ahead and do this. Okay, so you do need your polyatomic ion sheet for this. You do have to go ahead and crisscross these. I had to put the 2 in front of the Na to keep it balanced. The sulfate stayed together because it is a polyatomic ion. This is an acid, so it is going to be aqueous on the left. And again, sulfate has to stay together. This is not an acid, this is something that is ionic, so I'm going to get solid on the left. Oops. And that is all for tonight's video. Thank you so much for watching and have a great night.